Hello everyone and welcome back to the GCSE Maths Series. Today we're going to be taking a look at exam style questions for our similar shapes with specific focus on surface area and volume today. As always, please make sure to check out Maths Genie and look at my revision video before attempting this video. So, in this question we're told that we have two solid shapes A and B which are mathematically similar. The base of shape A is a circle with radius 4 centimeters and the base of shape B is a circle with 8 centimeters. So first things first, we can see that the length scale factor is equal to timesing by 2. So our length scale factor is 2. It then tells us that the surface area of shape A, so surface area of shape A is equal to 80 centimeters squared. And if you remember guys, we have scale factor here and we have, let's say, length, area and volume. So the ratio between smaller and larger shapes for length is in general going to be a factor k. Then we know our area scale factor is going to be a factor of k squared. Then we know that the volume scale factor is k cubed. So whatever our length scale factor is, we square it to get our ratio factor for A and cube it to get our ratio factor for the volume. We can also work backwards, so say they give us the area scale factor, we can square root it to get back to here, and similarly we can cube root it to get back to here. Okay, now we know our length scale factor is timesing by 2. We need to work out the surface area of our larger shape here. So our area scale factor, looking at our table, is going to be 2 squared. So 2 squared is going to be 4. That is our area scale factor. So we look at our smaller one, it tells us it's 80. So we do 80 times by 4 to get our larger one, which is 320 centimeters squared. Okay, it then tells us the volume of shape B is 600 centimeters cubed. So the volume is equal to 600 centimeters cubed. And remember, this is our larger shape we're looking at. Now the volume scale factor is going to be k cubed. So our k is 2. So our volume scale factor is going to be 2 cubed, which is going to be 8. Now to get from the larger one to the smaller one, we do 600 divided by 8 because we're going this way. So 600 divided by 8 is going to give us 75 centimeters cubed for our volume of shape A. Now looking at question number 3, it tells us that the diagram represents a large cone of height 6 centimeters and base diameter of 18 centimeters. The large cone is made by placing a small cone of height 2 centimeters and base diameter 6 centimeters on top of a frustum B. Calculate the volume of the frustum B. So the frustum is this part here. So we know that the A is put on top of B, right? So we need to work out our length scale factor. So our length scale factor is going to be timesing by 3. And I'll explain exactly how. So the two similar shapes are our small cone A and our larger one, this whole thing here. So what we need to do is see that the height of this cone is 2 centimeters, but the height of the larger cone is 6 centimeters. So 6 divided by 2 is going to be 3. So that is our length scale factor. So that means our area scale factor is going to be 3 squared, which is equal to 9. And our volume scale factor is going to be equal to 3 cubed, which is equal to 27. Now we can work out the volume of our big cone. So the volume of our big cone is equal to, using our formula right here, we have 1/3 times by pi times by 9 squared times by 6. So this is going to give us 162 pi. Now working out the volume of our small cone, we have 1/3 times by pi times by our 3 squared, so the radius of this part here, so 3 squared, times by our height of 2, which gives us 6 pi. Now, to work out the volume of the frustum, we can see from our question, it tells us that the frustum is comprised, well, not comprised, our cone is is the smaller cone put on top of the frustum. So we have our larger cone, which can be broken down into a frustum shape and a small cone. So the way we work out the volume of the frustum is to do volume of the big cone minus the volume of the small cone. And this will tell us the volume held within this section of our big cone. So this is going to be 162 pi minus 6 pi, which is going to give us 156 pi centimeters cubed. Okay, now looking at the next question, we're told that two cylinders, P and Q, are mathematically similar. The surface area of cylinder P is 90 pi centimeters squared. And the surface area of cylinder Q is 810 pi centimeters squared. The length of cylinder P is 4 centimeters. Work out the length of cylinder Q. So the way we do this is to work out our area scale factor first. So area scale factor is equal to 810 pi over 90 pi. So we get our area scale factor to be 9. And remember, we have our length, area, and volume as a ratio is going to be k squared, and k cubed. So if we have our 9 to be here, this means our k is going to be the square root of 9, which is 3, and this is going to be 27. So to work out our length, we have our smaller length of 4 centimeters here. So we need to do 4 centimeters times by our length scale factor, which is 3, and so our length of cylinder Q is 12 centimeters. It then tells us that the volume of cylinder P is 100 pi centimeters cubed, and we need to work out the volume of cylinder Q. So we need to times by our volume scale factor, because cylinder P is our smaller cylinder, so we need to times it by 27. So 100 pi times by 27 gives us 2,700 pi centimeters cubed. Okay, now looking at our next question, we have two cones, P and Q, which are mathematically similar. It tells us that the surface area of P, so the surface area of P is 24 centimeters squared, and the total surface area of Q is 96 centimeters squared. And we need to work out the height of cone P. Oh no, it tells us the height of cone P. We need to work out the height of cone Q. So we first work out our area scale factor, which is going to be 96 divided by 24, which is going to be equal to 4. That is our area scale factor. Our length scale factor is going to be, from our table, is going to be 4 square rooted, which is 2. So to go from our smaller cone to our larger cone, we times by our area scale factor. Well, our length scale factor, sorry. So we have our height of cone P is 4, so we need to times by 2 to get 8 centimeters as our larger length, our larger height. The volume of cone P is 12 centimeters cubed. Work out the volume of cone Q. So our volume scale factor, guys, is going to be 2 cubed, which is going to be 8. So we have a volume of cone P, which is 12 times by 8 to work out our larger one, and we get our volume of cone Q to be 96 centimeters cubed. Okay, guys, that's going to conclude today's video. Hope you guys enjoyed. Hope you guys felt like you've consolidated your knowledge. As always, please make sure to like, comment, and subscribe, and I'll catch you guys in the next video.